Hello, good morning everyone. My name is Shurchan and I'm from the CSC department. Today, I'm going to elaborate about and give a presentation on production of biodiesel from waste of cooking oil. Introduction to biodiesel. Uh, Here comes the definition of biodiesel. It's a biodegradable, renewable, and non toxic fuel, which is usually made from vegetable oils, animal fats, or recycled cooking grease. It's an eco friendly alternative for petroleum and diesel fuel. Because it's eco friendly, it reduces pollution around us and also conserves uh, fossil fuels, such as diesel or petroleum. And it also reduces greenhouse gas amount in our surroundings. Benefits of biodiesel. It's environmentally friendly as it reduces greenhouse emissions and is economically friendly too as it creates jobs in many sectors, and it's also a safer and sustainable fuel. Coming to the waste cooking oil. Why recycling waste cooking oil? Because it is environmentally beneficial as it is a renewable source of energy. It can also be used to make bio-based plastics. Benefits over conventional fuels. It's renewable, so it saves energy and cost, and it is highly cost efficient and is highly energy efficient too. Government also provides tax incentives for recycling of cooking waste oil. Government also provides reduces the tax and gives some incentive to the the products which we will create the waste cooking oil. Key properties of waste cooking oil. It can be used as a raw material for biodiesel and many fuels. Biodiesel produced from it can be used to remove soaps, catalysts, and alcohol residues. Challenges in using waste cooking oil for biodiesel production. Quality of waste cooking oil may vary, which may lead to disruption of biodiesel production process because of being gathering waste cooking oil from many different areas such as hotels, restaurants. The different food which is cooked in that oil may vary, so the impurities may vary too. So this may disrupt the biodiesel production process. It is difficult to maintain a steady supply of waste cooking oil. It is difficult to collect and store the waste cooking oil from multiple sources because by mixing it, you may increase the impurities among everything and it may disrupt the process again. And regularly getting the supply of waste cooking oil is also a hard part because the farming of cooking oil may take a large amount of time because there are different types of cooking oils and gathering them all and trying to maintain a steady supply and trying to recycle, it's a very large process. So it can't be done that easily. And coming to the process of biodiesel production, the methods generally used to turn waste cooking oil into biodiesel are transesterification. This is the most commonly used method among every other methods. And supercritical methanol transesterification. This is an updated method of transesterification and enzymatic transesterification in which enzymes are used to do the transesterification process. And pyrolysis, and there are some more processes which are not commonly used. These are the most commonly used ones, and among all of these, transesterification is the most used one, and that's the one we are going to discuss about today. Steps in biodiesel production. The production process in biodiesel from waste cooking oil consists of many methods. They are collection of waste cooking oil from different sources, as we talked about earlier, collecting them and storing them at a separate basis. Purification, purifying this waste cooking oil collected all together. And transesterification, separation and purification of biodiesel, which is formed of transesterification, and separating the impurities from it and purifying it and get in the form of pure biodiesel. Glycerol. Glycerol is a byproduct which is produced from transesterification and to separate the biodiesel and glycerol, which is combined when from the transesterification occurs. Uh, Coming to the collection of preparation of cooking waste oil. Uh, Collection of waste cooking oil gathered for restaurants, hotel, households, or food processing units. Purification of waste cooking oil. The oil is filtered to remove food particles and impurities. Heating may require to remove water content. If there is any sort of water content in the oil, it may be removed by heating. And oil is filtered to remove any food particles or impurities because many sorts of food are made in the waste cooking oil. So oil is filtered to remove the food particles and impurities. Come to transesterification process. Chemical reaction. Waste cooking oil reacts with methanol or ethanol generally in presence of a catalyst, usually sodium hydroxide or potassium hydroxide. This reaction produces biodiesel and glycerol. As you can see in this figure, methanol is mixed with any crude oil or waste oil in a reactor, which gives us biodiesel and glycerol. And this glycerol is then, these both are separated to give pure biodiesel and glycerol. which is high yield, uh, is also no waste in this product. Coming to catalysts used in transesterification, alkaline catalysts generally most commonly and generally sodium hydroxide and potassium hydroxide are used in this process because they are highly efficient. Acid catalysts, they are not commonly used, but when they are used when the oil has high amounts of fatty acids. This is due to the fatty acids are due to big food being fried in the or cooking oil or something. You can use the acid catalyst to remove the fat levels in the oil and use it to create the biodiesel. The reaction of the transesterification process is going to be triglyceride, which is combined with methanol, which gives us a biodiesel, and glycerol, which is combined, just separated by using these catalysts. Coming to separation of biodiesel from glycerol, separation process. After the reaction, the mixture is allowed to settle. The previous reaction which we discussed, then the mixture is allowed to settle. Biodiesel is lighter than glycerol, so it floats, and which glycerol settles at the bottom, which then they are both are separated. The biodiesel washed and purified to remove residual methanol catalyst, which is added. Purification methods: water washing to remove impurities, drying the biodiesel to eliminate any remaining moisture and water content, filtering through activated charcoal to enhance purity. Uh, After getting the biodiesel by drying and removing the entire water content, filtering it through the activated charcoal increases purity and also increases the quality of the biodiesel. Properties of the biodiesel. The physical properties are viscosity, density, flash point, and cetane number, which are generally with all fuels. Performance characteristics comparable to petroleum-based diesel in engine performance. So it is as good as a non-renewable resources, but it's a renewable resource, so it's economically friendly too, and also it's renewable, so it's good for the environment and ecology and personal uses because it doesn't consume too many resources because it's recycled. Lower emissions of CO2 particulates and sulfur because of it not being it's recycled and it's a recycled product. It doesn't emit too much of carbon dioxide particulates and sulfur, which helps us protect our environment and reduces pollution around us. Applications of biodiesel: uses in transportation, can be used in diesel engines with little to no modification. Can be used in conventional diesel engines, which are mostly run by in cars and by any trucks or something. Uh, with biodiesel can also be used in it. A substitute or blend with conventional diesel, which you can combine, you can interchange with the two fuels, like using conventional diesel at one trip and the return trip you can use biodiesel. Other applications can also use the biodiesel for heating as heating oil or power generating. You can use it in generators and in various industrial applications. Advantages of biodiesel over conventional fuels. As we talked about earlier, it reduces greenhouse gases and it also decreases air pollution like carbon monoxide or particulate matter, which reduces the pollution around us by a lot and by significantly. And if we can manage to convert our oil, the petrol fuels we use to biodiesel, we can reduce the pollution content in our air by much, significantly large amount. Economic and benefits: supports the local economy by reducing reliance on imported oil. So it can make our economy stable and uh, give us a source of energy which can make us strong in terms of energy resources, and is also a very supporting thing to our economy, and it also creates many jobs in the biodiesel industry because of there are many processes in making this, such as collecting the waste cooking oil from many places and processing it through the entire transesterification process and delivering it to the consumers and reaching it out to the vehicles, etc. So it can also give many jobs for unemployed people, which may help in creating a large scale industry. Challenges in biodiesel production: issues with waste cooking oil, inconsistent quality and contaminants because of the cooking oil being collected from many places. Uh, the the different amounts of items cooked in the oil may vary, and the impurities may also vary because of the all of them combined, which may lead to inconsistent quality and many different sorts of contaminants which may not be removed as easily by filtration or by filtering through the entire oil. This requires pre-treatment and purification by large amount and which may not guarantee the purification of the cooking oil. Economic and scalability challenges. High production costs compared to conventional diesel. This is true because when you are purchasing the waste cooking oil and you are transferring it and you are processing it through a factory and doing all this process and delivering it, you're definitely gonna cost more than a diesel because the diesel is a direct product and this is a recycled product. So due to all these processes and the additional cost of the biofuel, it may require a large amount of money, but not gonna be too much like expensive from the conventional diesel. But yeah, it's gonna be high. The cost is gonna be high. Scaling up for industrial use can be difficult. So due to this more cost, high production cost, many people may not be willing to be interested to produce the biodiesel. Future of biodiesel from waste cooking oil. Technological advancements, improvements in catalytic processes, and new methods to reduce costs. Uh, Sustainability, increasing use of waste oils from various sources to make biodiesel more sustainable. Integration of waste oils from food industries to large-scale production. Because of using these waste oils from various sources, you can try to make the oil more sustainable by uh, storing it at different warehouses, and when the stock is low you can call the you can bring out the oil from different other warehouses, so this can make the sustainability more easy, and you can take and collect and store the stock whenever needed. Integration of waste oils from food industries on large scale production. You can make a deal with the food corporations and which make food at large amounts, and you can exclusive sign a deal with them and take the waste cooking oil for yourselves for recycling. And coming to the conclusion of the presentation, biodiesel from waste cooking oil is eco-friendly and economically viable alternative for fossil fuels. Because it's an eco-friendly alternative, it's obviously better than the diesel, but it's also somewhat economically viable because it may lead to a huge revolution in industry. It reduces pollution. It's also it's also equivalent to a fossil fuel, so it may reduce our use of non-renewable resources, which are now currently being mostly used, which may like increase our energy sources and also reduce our reliance on the fossil fuels. With advances in technology, biodiesel production from waste oils can contribute significantly to reducing environmental impact and dependency on non-renewable resources. As I just talked about earlier, it may reduce our dependency on non-renewable resources. So, with more advancing in technology, more more likely using non-renewable resources, we should switch to renewable resources such as biodiesel, which may help conserve our non-renewable resources and restore them for our future generations. My final thought on this presentation and this process is transitioning to a better, sustainable, recyclable biofuels is crucial for a cleaner, greener environment for our future generations. And the references I've taken are from these websites, Science Direct and Nature, and some of the references are taken from different websites on the internet. Uh, thank you. Thank you for listening to the program.